Okay, welcome back. Happy Monday. Today, lesson number 25, getting down near the end here. For the first time, I think, we can see the final exam up on the board. That's pretty cool. So it'll be here before we know it. Today we're covering quadratic models. That's lots of word problems involving quadratics. Coming up on Wednesday is quest number 4. The material on the quest is lessons 19 through 24. Today is 25. Today is not on Wednesday's quest. Okay, and then when we come back from Thanksgiving break, things are really going to motor. On Monday coming up after Thanksgiving break, we've got another day of hard material. Wednesday after break is our review day for test number 2, which is Friday after break, right? So we're going to have quest 4 coming up on Wednesday, and then Friday right after break, we've got our second test. Any questions on the calendar? Okay, then let us jump in here. At the top of page 201, in this lesson, we tackle some word problems that lead to quadratic equations. We'll start with number 1 here. A farmer has a rectangular garden plot surrounded by 200 feet of fence. Find the length and width of the garden if its area is 2,400 square feet. All right, let's give this a shot. Okay, so because it is a rectangular plot, we draw a rectangle, and we might as well label that rectangle with L's and W's. Notice that I put 2 L's and 2 W's, not just one of each. Okay, so it says that the rectangular garden plot is 200 feet of fencing. That's what's going around the outsides. So in terms of a geometry word, that 200 feet of fencing, are we describing area or perimeter for that rectangle? It's the perimeter. You have 200 feet of fence, right? It's not a measure of how much space is inside. It's a measure of how much stuff goes around the outside. So because that's a perimeter, we can write down a perimeter equation. So we know that if you add all the sides, you're supposed to get 200. So we can say L plus W plus L plus W is 200. Or combining like terms, 2L plus 2W equals 200. Okay, that equation is all well and good, but I'm going to recommend that you use a different version of that same equation. Here it talks about this thing called the semi-perimeter. In all likelihood, when you took your high school geometry, you did not talk about the semi-perimeter. But we can make a guess right now as to what that is. In math, what does semi mean? Yeah, but more precise. Yes, not all the way, but precisely. Semicircle. How much of a circle is that? Half, right? Semi is half. And so the semi-perimeter is half the perimeter. Okay, well, if the perimeter is 200, then how much is the semi-perimeter? 100. That's easy, right? But if you're doing half, then instead of doing 2 lengths, you are doing a single length. And instead of doing 2 widths, you are doing a single width. Makes sense, right? Just 1L plus 1W is going to be half of what you had when you did 2 L's plus 2 W's. Turns out that equation is much, much better than the blue equation. You could see me after class if you want to know why, but we're just going to use this equation when the time comes. Let's move on to the next part of this problem. It says its area is 2,400 square feet. Okay, what's the formula for the area of a rectangle? Length times width. Okay, we now have 2 equations, one green, one orange. Those 2 equations each have an L and a W. If I were to change this bottom equation here real quick, let's just change this temporarily to something like 3L minus W equals 2,400. And then the green equation right there. You guys remember we did systems of linear equations way back when? Remember we did the substitution method? Right, 2 lines intersecting, we'd find that point of intersection. We remember this, right? Nod your heads, pretend you understand. Yes, yes. Okay, so we're going to use the same kind of technique here. We're going to do the substitution method. Let's get rid of this and put it back. All right, the substitution method meant solve one equation for one letter and substitute that into the other equation. You got lots of choices. You could solve green for L or green for W, or solve orange for L or solve orange for W. If you solve orange for L, for example, That means you got to move this w to the other side by dividing. Yes? That involves fractions. You guys don't typically like fractions. So there's nothing wrong with solving this second equation for L or W, but it involves fractions. Whereas solving this first equation for L involves subtracting W, which is a little bit more friendly than the fraction game, okay? So let's choose that one because it's friendlier. So we will solve that equation right up there for L by subtracting the W from both sides. So we get 100 minus W, fair? And then we are going to take that and substitute into the orange. Instead of this L, what are we putting? 100 minus W, right? It's a straight substitution. It's just like we did before with the lines. So this equation now becomes, instead of the first L, it's 100 minus W times, what was there after the first L? W equals 2400. Does everybody see that substitution step? Place the L with 100 minus W. Okay, it looks like I've done everything correctly. But if I solve this equation, I'm going to get the wrong answer. So what mistake did I make? New parentheses. That L was a single thing, but now it's become two terms. It needs parentheses. It's supposed to be all of L times W. That's what it said. So now that we've got the parentheses, we're going to get this one right. But without parentheses, it was wrong. Okay, let's distribute on the left-hand side. So we go 100 W minus W squared is 2400. And we say, oh, finally, it's starting to look like something we've seen before. This is like a standard-looking quadratic equation, right? And for many quadratic equations, the goal is what number on one side? 0. So let's move that 2400 over to the left-hand side. So I'll subtract that. In fact, why don't I shuffle around the terms on the left-hand side first? I typically like my W squareds to be the first term. So I'm going to make it a negative W squared first. And then what symbol am I putting in front of this 100W? Plus, right? Because it was positive 100W. So we've got to bring that in. And now we're going to, so that was just rearranging. And now we'll subtract the 2400. And now it is equal to 0. And that is a standard form quadratic equation, right? W squared, then W, then a constant, equal to 0. Okay, and we have techniques that we've recently learned for solving standard-looking quadratic equations. One method is to factor, if it factors. The other method is the quadratic formula. Either way, you're going to get the same answers. This one does happen to factor. So I'm going to say, use the box method or the quadratic formula. You'll get it to factor. And then I'll write down the two answers down below. And so after all of that work, you end up getting W equals 40 or W equals 60. Okay, but this problem said find the dimensions of that rectangle. And even though we have two numbers, those are not two dimensions. Those are two different rectangles. There's one rectangle where the width is 40 and a completely separate rectangle where the width is 60, and we still need to find the length for both of those rectangles. Easiest place to go is this green equation here. The L is 100 minus the W. So we're just going to take those two W's and substitute them into this equation to find the L's. Let's do that down here. So this is L equals 100 minus W copied from above. So in this case, L is equal to 100 minus what number? 40. So there the L is 60. And over here, 100 minus the W, in this case 100 minus the 60. Now we get L is 40. So we tell our farmer there are two solutions to this problem with his or her 200 feet of fencing. They could either make a rectangle where the width is 40 and the length is 60, or where the width is 60 and the length is 40. Actually, it turns out to be the same rectangle. Either way, it's a 60 by 40 rectangle. But technically, there are two separate solutions to this problem. Any questions on that? No, this is atypical. Oftentimes the two solutions are completely different numbers. Yeah, oh yeah, there's always two solutions, but it's atypical that they were really just the same rectangle twice. Yeah. Other questions on this one? Okay, let's move on to the next page. All right, so this one involves a baseball being thrown. Here's the setup. The formula for the height of a baseball thrown into the air is h equals negative 16t squared plus 64t plus 4, where h is the baseball's height in feet and t is the time in seconds since it was thrown. Okay, lots of stuff going on in this one, so let's be clear about what the setup is here. Imagine that you take a baseball and you throw it straight up and it comes straight back down, okay? At every moment in time, so the moment I release this baseball, we're going to take our stopwatch and we're going to start it, okay? And the ball is up in the air and the time is moving and the ball comes down, and then I guess I can stop the clock when I catch it again, okay? And at every moment in time, this baseball is a certain height off of the ground, right? And this formula right here says, hey, if you just tell me what number is on the stopwatch, like if we're watching this as a video and we could pause it at any moment during this baseball's flight, just tell me what number is on this stopwatch, plug that value of time in for the t's, and whatever this formula spits out, that's how high the baseball is at that moment in time, okay? Let's try it. If we plug in t equals, so we're going to fill in this table here with some t values, and we'll fill in the h values. If you plug in t equals 0 in both places, then what do you get for the whole thing? Just 4, right? Everything zeroes out except for that plus 4, so put it right there. What does that mean? It means the moment the stopwatch says 0, which is right as I am releasing the ball, but before it's gone anywhere, where is the ball? The ball is 4 feet off the ground. That's what that is saying. It's telling you the height of the ball off the ground in feet, okay? Why isn't it 0? It's not starting on the ground, right? You're throwing it from 4 feet up. That's what this is saying. Okay, let's go ahead and plug in t equals 1 up there. So we'll do this one out on the side. H equals negative 16 times 1 squared plus 64 times the same 1, and then always plus 4. Okay, so we're just substituting t equals 1. So negative 16 plus 64 plus 4. What is that? 68, 58, 42, 52, 52. So what does that mean? It means 1 second into this experiment, 1 second after I release this baseball, how high off the ground is it? It's 52 feet off the ground. That's what this is saying, okay? All right, you plug in 2, 3, and 4 in exactly the same way. I'm just going to save time and write the answers here. Turns out this is 68, 52 again, 4 again. Okay, we are going to plot these 5 points on that graph paper over there. The horizontal is time in seconds, the vertical is height in feet. So go ahead and carefully plot 4 points. I'm going to have to do some estimating because we don't have an awful lot of grid lines here. And once you've got your 5 points plotted, go ahead and connect them with a smooth curve called a parabola. I'm not sure where that one was. 0, 4. Okay, so there's our parabola. I want to be clear. If you throw a ball to a friend, the path of the ball is going to be a parabola. It looks an awful lot like that's the path of the ball. That is not the path of the ball. This ball, for our purposes, is going straight up and coming straight back down. The vertical is the height. The horizontal is not where the ball is located horizontally in space. The horizontal is time, okay? This ball is going straight up and down. So you can imagine this ball going straight up and coming straight back down on the y-axis, except you wouldn't see anything if we just plotted it on the y-axis. So instead, we're stretching it out this way, okay? But the horizontal is time. It's not the position of the baseball. Okay, let's start filling in here. Coordinates of the highest point, what is it? 2, 68. Okay, fair enough. And the fact that that is the highest point means we can write down two, well, we can explain what the 2 and the 68 both mean. It says the baseball reaches its maximum height at how many seconds? 2 seconds. The maximum height of the baseball is how many feet? 68, okay? So those numbers both mean something in terms of this baseball reaching its highest point. Okay, so it turns out that that example, the equation, the negative 16t squared plus 64t plus 4, is a special case of a more general formula. It turns out that any falling object that is affected only by gravity, which is the reason this baseball is falling back to Earth, follows the same exact formula, no matter what it is or where it is. So here's the formula. It says h equals 1/2 gt squared plus v sub 0 t plus h sub 0. Lots of letters there. It looks complicated, but once you know what's going on, it's really not. I said that the reason this ball is falling back to Earth and not floating off into space is gravity. G is gravity. G is the acceleration due to gravity. It's just a straight number. Here on Earth, acceleration is negative 32 feet per second per second. It's written right here, negative 32. I'll put units in. You don't need to worry about them, but it's negative 32 feet per second squared. Whether you are dropping a piano or a baseball, it is negative 32 feet per second squared. Okay, the t squared, well, we saw the t squared in our formula. That's just time. V sub 0, it's written up here. It says it is the initial velocity of the object, whether it's a piano or a baseball. V sub 0. It's two symbols, but it's really just one single number. The V is supposed to tell you it's a velocity. The 0 is supposed to tell you the time on the stopwatch. If the time on the stopwatch is 0, well, that is the initial moment that we're starting this experiment. And so in physics, a lot of the time, if you see a subscript of 0, that means at the start of the experiment, when the stopwatch reads all zeros, okay? So v sub 0 is the initial velocity. H sub 0, well, H stands for height here. The height when? What does that 0 tell us? At time equals 0. So this is the initial height of the object, okay? At the moment you release it. And so for our example, we got this. Okay, well, let's see. Why was there negative 16 here? Well, look, it's a 1/2 times g, right? And g here on Earth is a constant negative 32 in every problem here on Earth. So 1/2 of negative 32, that's the negative 16. Where might the g, the force of gravity, the acceleration due to gravity, where might that be different? I'm telling you, it's constant negative 32 here on Earth. Yeah, like where? Yeah. Doesn't Mars have a different gravity than us? And you've seen video of folks hopping around on the moon like there's hardly any gravity. Well, there's gravity. It's just a lot less than the gravity here on Earth. So on Mars and on the moon, the g would not be negative 32. It'd be a different number. I'd give it to you in a problem like that. In our case, we had a 64 here. Well, that 64 is playing the role of this v sub 0. That means that for the baseball, the initial velocity was 64 feet per second. Person threw it up at 64 feet per second. The moment it left that person's hands, gravity started taking hold, and it was not moving at 64 feet per second, right? Like a moment later, it's maybe going like 63 feet per second, and then maybe 60 feet per second. It eventually slows down until it reaches the top and then starts coming back to Earth, right? This h sub 0, how much was it for our example? 4. Was 4 the initial height of the ball? When we filled in the table, didn't we discover that the ball was initially 4 feet off the ground? Okay, it makes sense. All right, so let's suppose that we use that fancy formula here for number 4. A tennis ball is thrown into the air with an initial velocity of 25 feet per second from a height of 8 feet. Write a formula that gives the height of the tennis ball at time t, and the hint is, I'm just copying that formula from up above. Let's give it a shot. H equals 1/2. We change the g to a number. What is g on Earth? Negative 32. We just put it. Negative 32. Copy of the t squared plus the next number here is v sub 0. It's given in the problem. What is it? V sub 0 is a number. V sub 0 stands for velocity initial. 25. Copy the t. Initial velocity is 25. We just copy that right there. I'm continuing to copy here plus h sub 0. That stands for height initial. It's given in the problem. What is it? 8. So all we did was copy our generic formula there, but we changed g to negative 32. We changed the v sub 0 into the number given in the problem, and we changed the h sub 0 into the number given in the problem. The 25 is touching the t. Yeah, that's it. The only other thing to do is to multiply the half and the negative 32. So we'll just do that one last step, and this one is done. And there you go. So that is the height of this tennis ball at any moment in time. And it turns out that armed with that formula, we can do a lot of work. We can figure out how long it takes for the tennis ball to hit the ground. We can figure out how high the tennis ball is 3 seconds after we let it go. We can figure out how high the tennis ball is at any point. We can figure out when the tennis ball reaches its maximum height and how high it gets. Using calculus, you can actually use this formula to figure out the velocity of the tennis ball at any moment in time. It changes, right? It's going quick in the beginning, and then gravity takes hold of it, and it starts going slower, slower, slower until it gets to the top where it's momentarily not moving at all. And then it starts to fall down slowly at first and faster, faster, faster. Calculus can tell you how fast that ball is moving at any moment in time. All we need is that formula, which we've got. Okay, so you are going to start the activity on the next page. It is a continuation of this baseball example. I will walk around.